we present grasping trajectory optimization with point clouds. In this work, we consider the following setup. A robot is facing a set of objects in its task space. First, we assume that there's a grasp planning algorithm that can generate grasps of these objects. Our goal is to generate trajectory of the robots to pick up these objects. In our method, first, we represent the robots using point clouds sampled on the surface of the robots, and this representation can be used for any robots. Second, we represent the task space of the robots using point clouds as well. We can convert these points into a signed distance field of the task space. There are voxels with negative signed distance and voxels with positive signed distance, so we can use the SDF for clear avoidance. In our optimization problem, we have a goal-reaching term which encourages the robots to reach one of the planned grasps. This term is based on the pairwise distance of points sampled on the robot gripper. We also introduced a standoff pose in our optimization problem. This term encourages the robots first to reach the standoff pose before reaching the final grasping pose, which can avoid collisions between the target objects. For collision avoidance of the task space, we leverage our signed distance field. We compute the signed distance of the points sampled on the robots against the signed distance field. So finally, we set up a constrained optimization problem where we solve for the joint positions and the joint velocities of the robots. The optimization problem consists of an objective function and a set of constraints. We first conducted experiments in the Panda simulator. We have enabled the fetch robots and the Panda robots to grasp objects from a shelf scene and a tabletop scene in the Panda simulation, where we generate trajectories using our proposed algorithm. In the real world, we combine object detection and segmentation, grasp planning from the contact grasp nets, and our algorithm for trajectory optimization. We have enabled our fetch robots to grasp objects in a shelf scene in our lab, and the tabletop scene according to the single replica benchmark. We have shown improvements over trajectory planning using the MoveIt ROS package. Thank you for listening.